May 17th, 2017. Baz made a new diagram here on the Walensky-Taylor diagram. If you'll notice, there's a blue area, there's a green area, there's a yellow, and there's a red. And those basically stand for population 1, population 2, population 3, and population 4 stars. The difference between those populations and why I did this is because establishment science, they've based everything off of a Big Bang creation event, where the entire universe just popped into existence with a giant bang. With stellar metamorphosis, the universe is eternal, so it essentially recycles itself. So to find out where the dead stars are and to find out which ones are the youngest, you have to actually examine them based on their properties, what they're actually doing, what they actually look like. In Big Bang creationism, young stars have more iron and metals. Those are called population 1. Old stars have more helium and hydrogen. Those are population 2. And ancient stars have all hydrogen and helium, which are called population 3. And much to their dismay, no population 3 stars have been found. I mean, they might claim it to be true, but that's not true at all. No matter what you do, a star is going to have all the elements. So classifying them based on that is a bit short-sighted, if you will. Population 1 in stellar metamorphosis are the young stars. They're not the very old ones. They are comprised of plasma, and they are stars in the visible light spectrum. So population 1 are the stars that we can look at the night sky and actually see with our eyes. Population 2 are gaseous matter that no longer have strong visible light spectrums. Those also radiate strongly in infrared. Those are objects like brown dwarfs, gray dwarfs, and Jupiter-sized objects as well. And also they can reflect a lot of light because their surface areas are still really, really big, but the majority of the light they produce is not there anymore. They can't produce a lot of visible light. Population 3 stars are mostly solid and liquid material. It's where the gas is already condensed into liquids, and this isn't just cool liquids. Consider hot liquids as well, like lava, liquid rocks, things like that. Think magma, lots and lots of magma. So we're talking like a hellish interior. And just because it's cool on the outside of the star doesn't mean that it's cool all the way through. That's very short-sighted reasoning. Doesn't matter how far a star orbits its host, it can still be a hellish interior. It doesn't matter how far it orbits, and it doesn't even need to be orbiting a star to begin with. It could be a rogue object doing its own thing at any size. So any of these objects could be rogue, doing what they want to do. Any of them. And then the population 4 are dead stars. They don't have appreciable magnetic fields. These are the Venuses, these are the Mercuries, and they're mostly solid. So, we know they're solid because they don't produce a magnetic field. If there was fluid motion in the interior, there would be a magnetic field. But they don't have one, so there's that. And then you have your star guts, after they smash into each other. Those are things like Callisto, which is undifferentiated, the asteroid belt, meteorites, rings around Saturn, rings around all the gas giants, things like that. Those are the star guts. And basically, just to keep this in mind, that when you see population as defined by stellar metamorphosis, it's not going to be establishment's version. It's a bit backwards because they have old stars having helium and hydrogen. No, a young star has a lot of helium and hydrogen. Old stars are mostly comprised of rocks and minerals, things like iron and magnesium and oxygen in the crust, just like Earth and silicon, things like that. Alright guys, I'll link this paper to the bottom of the page. Take it easy.